Hello, my dear students. Welcome to IMS GATE Academy. Myself, Sandeep Adari. So, the motto of this today's session here is I want to cover all the soil mechanics. And for the students who are preparing for Coal India Limited and Andhra Pradesh Public Service Commission, and also who are preparing for the exams related to the state level PSUs and all, I'll cover the entire soil mechanics in today's session. So, my dear students, let us start the session without wasting the time. So, first topic I would like to start with properties of soil. Okay, I would like to start with what, sir? I would like to start with the session on properties of soil. Sir, you name any technical exam. If it is from civil engineering and if you have geotechnical as a subject, then this question, the questions from properties of soil is very much important. Okay. So audio video clear, sir. Thank you. So let us start this one, my dear student friends. So how do you represent a soil? The first question is, how do you represent a soil? Okay. This is the first one which I want to tell you. Sir, how do we represent a soil here is, suppose if I consider this as a soil mass, in that there will be some soil particles, right? And the voids will be filled with either air or water. Now, my dear students, if I consider a three-phase diagram, means phase diagram, let us see. Here I want to show you a three-phase, okay. One second, my dear student friends. So, whoever is interested, students who are preparing for Coal India and APPSC or Telangana PSC, just share this video. So, here we have, this is voids. This is volume of voids. Here we call it as volume of solids. And if you consider here, this is air volume and this is what, sir? Water volume. So here you can write this as volume of air and this as volume of water. Now, my dear students, if I consider here total volume can be written as what, sir? Volume of voids plus volume of solids. Here, if I consider here volume of voids means what, sir? Volume of air and volume of water. So, how many constituents are there, sir? 1, 2 and 3. So, soil can be represented as a three-phase system. So, soil can be represented as what, sir? Three-phase system. And what is the state of the soil now? If you ask me, what is the state of the soil here, sir? The state of the soil is nothing but partially saturated soil. The state of the soil is what, sir? The state of the soil is nothing but partially saturated. Sir, what is partially saturated soil means? In this, voids are filled with both air and water. In this, you have to remember, my dear students, voids are filled with both air and water. So, I hope you are clear. How do you represent a soil, sir? Soil can be represented as a three-phase system. In which type of soil? In partially saturated soil. Now, if I consider in a fully saturated, if I consider fully saturated soil, here, if you consider in a fully saturated soil, my dear students, voids are completely filled with water. So here, volume of water will be equal to volume of voids and volume of air will be 0. So here, total volume can be written as what, sir? Here, total volume can be written as what? Volume of voids plus volume of solids. As air will be 0, it can be written as volume of water plus volume of solids. So how many constituents are there here? Volume of water and volume of solids. So 1 and 2. So soil can be represented as a two-phase system. Soil can be represented as what, sir? Soil can be represented as a two-phase system. And even if I considered in fully dry soil, my dear student friends, if I considered in fully dry soil, In fully dry state also, voids are completely filled with what, sir? Water. So here, sorry, voids are completely filled with air. So in a dry state, volume of water will be 0. Okay. So here if I consider total volume here, total volume can be taken as volume of air plus volume of solids. So the final point, and one more thing students, Telegram group link will be shared in the chat, Amma. Whoever wants this complete notes, if you can join our Telegram group link, in that you will get the complete notes of today's session. Okay. So here how many constituents are there? So two constituents are there. So soil can be represented as two-phase system. So my dear students, the final conclusion here, the note point I would like to tell you here is soil can be represented as soil can be represented as a three-phase. Soil can be represented as a three-phase and a two-phase system. How do you represent a soil, sir? A soil can be represented as a three-phase and two-phase. And where do you represent in three-phase, sir? Sir, soil is represented as three-phase in the case of which soil? Partially saturated. And soil can be represented as two-phase. In which type of soil, my dear student friends? Fully dry soil or fully saturated soil. So now, my dear students, let us understand what do you mean by void ratio? What do you mean by void ratio? So any kind of doubts you can ask me in the chat box, my dear student friends. So what do you mean by void ratio? Means void ratio is defined as volume of voids by volume of solids. Void ratio is defined as what, my dear students? It is nothing but volume of voids to the volume of solids. Now, my dear students, for any soil, if you take some soil, there will be some voids. It is impossible to have zero voids practically. So that is the reason, if you consider the range of void ratio, if I consider the range of the void ratio is always greater than 0. It is never equal to 0 because it can be never possible practically. And remember, sir, the void ratio for fine grained is always greater than the void ratio for coarse grained. Sir, this is a very important point. Usually student feels that void ratio for coarse grained is more when compared to fine grained. But let me tell you, the size of the void will be more in coarse grained, but void ratio will be less for coarse grained and void ratio will be more for fine grained, because when you add the number of voids, in fine grained the number of voids will be more, whereas in coarse grained size of void will be more. And remember, this is an important thing. You can take a rice, and if the rice is made into powder rice can be taken as fine grained and rice can be taken as coarse grained. So usually if you take this as a practical example, the number of voids will be more in fine grained and number of voids will be less in coarse grained, but size of void will be more. So void ratio is defined in this way, my dear student friends. Now, if you want to discuss about porosity, sir, in one of the interviews, they've asked percentage of voids, sir. Instead of porosity is nothing but volume of voids to the total volume. So what is porosity? N is nothing but the porosity here. So what is porosity is represented as N, and it is nothing but volume of voids to the total volume. Right. Now, my dear students, if I consider here total volume is written as volume of voids plus volume of solids. Now, here if I take volume of solids as common, it will be written as what, sir? VV by VS plus 1. Now, see students, here VV by VS will be equal to void ratio. So, total volume can be written as VS into E plus 1. So, if I substitute this, total volume is equal to Vs upon 1 plus E here. So, it can also be written as Vv by Vs into 1 plus E. Again, now my dear student friends, Here VV by VS is what, sir? It is nothing but void ratio. So porosity can be written as E upon 1 plus E. So students, I might be somewhat fast because I just want to cover each and every topic, sir. So here you should be cautious in this. So if you see here, numerator is less than denominator and void ratio. So the range of porosity can be written as what, my dear students? The range of porosity can be written as 0, n less than 1. So this is the range of the porosity. Okay, here denominator is more than numerator, so it will be always less than 1. Now in one of the 25 gate questions, sir, they told percentage of voids. Percentage of voids means VV by V into 100. That you have to understand that. Similarly, my dear students, after porosity, we have another terms called air content and void ratio. So student friends, if your friends are preparing for Coal India or APPSC, please try to share this link. Now, if you are having air content, what do you mean by air content, sir? What do you mean by air content? Here air content is nothing but what, sir? Air content is nothing but volume of air upon volume of voids. So what is air content here, my dear students? Here you should understand that air is present in voids. So how much percentage of air is present in voids? We call it as air content. Now, in fully saturated state, what do you mean by fully saturated? Just now I explained you. Voids are completely filled with water. So in this case, volume of air will be 0. Am I correct or wrong, my dear students? So in this case, air content will be taken as 0. But if you consider fully dry state, my dear student friends, if I consider here fully dry state, what do you mean by fully dry state, sir? Here voids are completely filled with air. So volume of water will be 0. And if you see, volume of voids will be equal to volume of air. In this case, air content will be taken as 1. So remember, my dear students, here air is a subset of voids. It can be equal to voids, but it cannot be more than voids. So if you see here, what is the range of air content, they can ask me. What is the range of air content, sir? The range of air content is 0 air content less than or equal to 1. Have you observed in porosity, it is not equal, but here it can be 0 or it can be 1 because void ratio cannot be equal to 0. I hope you are following, my dear student friends. If you have any questions or anything, please feel free to ask me. Now we have degree of saturation. What do you mean by degree of saturation, sir? Sir, saturation, the word comes means it is related to water. So degree of saturation, SR is given by the formula volume of water upon volume of voids. Sir, now people can ask me, sir, how if they ask me in percentage? In percentage means you just have to multiply with 100. So here the degree of saturation range will be 0, SR less than or equal to 1. In here it will be completely vice versa, sir. In dry state, degree of saturation will be 0 and in fully saturated state it will be equal to 1. So if you want to have the clear picture, we have studied about void ratio, porosity, air content and also degree of saturation. So now let us study about the percentage of air voids, my dear students. So what do you mean by percentage of air voids, sir? Here percentage of air voids is taken as Na. Na is equal to what, sir? Volume of air upon total volume. So usually if I want to get percentage of air voids, volume of air divided by volume of voids into total volume by, can I multiply with volume of voids and volume of voids? So this will become air content and this will become porosity. So percentage of air voids can be written as N into AC. And remember, my dear students, you should also remember that air content plus degree of saturation is always equal to 1 or 100 percentile because they can give you degree of saturation and they can ask you air content. So here the range of percentage of air voids If you see, my dear students, the percentage of rain air voids is 0, Na less than or equal to 1, N. Because if you substitute here air content 0, then it will be 0. If you substitute air content as 1, it will be N. So here the percentage of air voids, I hope you are clear, my dear students. Now let us understand, what do you mean by water content? What do you mean by water content? So here if I consider water content is defined as weight of water by weight of solids. Sir, as I told you, if you consider in dry state, water content can be equal to 0. So water content range can be greater than or equal to 0. Or in some cases, weight of water can be more than weight of solids. So it can be greater than or equal to 0. So now they can ask you which is the accurate method. So we have different methods, sir. The accurate method to determine water content is oven drying method. Which is the accurate method to determine water content, sir? The accurate method to determine water content is nothing but the oven drying method. Sir, in oven drying method, we considered a temperature of 105 to 110 degrees. And it will be for a duration of how much? 24 hours. Why usually this temperature, sir? The boiling point of water is 100 degrees. And if you overheat it, the soil will lose its nature. So here you always remember water content is equal to weight of water by weight of solids, and this is the accurate method in determining the water content. Now people has to wait. Sir, see, you will take a weight of soil and you will put in a oven drying for a duration of 24 hours. After that you will remove that soil. Now that soil is what's a dry weight. So weight of water is what, sir? Total weight minus dry weight. And if you consider water content, it is given by the formula total weight minus dry weight, or dry weight or solids weight, both are same. So if you multiply with 100 means you are multiplying to get in percentage. So water content. Now some of the students might ask me, which is the quickest method to determine water content? What, sir? Which is the quickest method to determine the water content? Here if you ask me what is the quickest method to determine water content is calcium carbide method. And this will hardly takes 5 to 10 minutes, sir. Which is the quickest method to determine water content? It will hardly takes how much? 5 to 10 minutes. So this is called calcium carbide method. Now here what I would like to tell you here is, when calcium carbide method reacts with water, what, sir? When calcium carbide method reacts with water, it will be releasing calcium hydroxide and you will get some C2H2. So they can ask you, what is the gas released in calcium carbide method? So my dear students, what is the gas released in calcium carbide method? It is nothing but the acetylene. Okay. So you can ask me which is the accurate method? It is oven drying method. Which is the quickest method? Then it is the calcium carbide method. We have another methods like sand bath method. No need to go in detail, but in the multiple choice question they can ask you. Or radiation methods we have. And also we have torsional balance method. So these are all the methods to determine the water content. Now, my dear students, you can ask me, there are some unit weights also. What are the unit weights of soil? First one we have is what, sir? Bulk unit weight. First one what we have? Bulk unit weight. What is bulk unit weight here? Gamma is equal to total weight by volume. In this total weight, there can be weight of water and weight of solids. and weight of air. But weight of air is negligible, so we will not consider this. And if I consider total volume, it will be considered as what, sir? VV plus Vs. Again, VV can be written as what? VA plus VW. Now, my dear students, if you considered here, what I would like to tell you is, this is gamma bulk unit weight. Okay, there will be also called as saturated unit weight. What, sir? There will be saturated unit weight. What is saturated unit weight? It is gamma sat. Gamma sat is equal to what, sir? Weight of water plus weight of solids upon total volume. Now, some of the students might ask me, sir, what is the difference between these two? Here, total volume means volume of air plus volume of water only. Sorry. Here, total volume means volume of water plus volume of solids only. Here, volume of air will be 0. So, you have to understand this, my dear students. Similarly, if you ask me dry unit weight, what, sir? If I ask you dry unit weight, sir, actually dry unit weight or saturated unit weight are nothing new. They are actually bulk unit weight, but based on the state of the soil, they will change. So here dry unit weight is given as weight of solids upon total volume. So dry unit weight is what, sir? Weight of solids by total volume. Am I clear, sir? Just a second, students. 1 minute. Just go through the notes, sir. So here, please understand, this is nothing but what's a dry unit weight. Similarly, we have unit weight of solids. What, sir? We have unit weight of solids. So what is unit weight of solids, sir? This is nothing but represented in the form of gamma S. So gamma S is equal to what, sir? Weight of solids by volume of solids. What is gamma S here? Gamma S is nothing but weight of solids by volume of solids. So for any given soil, weight of solids will be constant and volume of solids will be also constant. So for any given soil, unit weight of solids will be always constant. So you should remember this. Similarly, if I ask you unit weight of water, what is unit weight of water, sir? It can be written as gamma W is equal to weight of water by volume of water. This is called as unit weight of water. And here in unit weight of water, gamma W can be written as 1 gram per centimeter cube or 1 ton per meter cube or 9.81 kilonewton per meter cube. So these things are standard. Now let me tell you one short trick here, sir. Whenever they have given any problems, when you are using gamma W, if the volume is in centimeter cube, take 1 gram per. And if it is in meter cube, do it with 1 ton. If the final answer is in kilonewton, suppose you got final answer as 2, that time you multiply with 9.81, sir. Because this will help you in calculations and where you don't have calculator. Are you getting, my dear students? If you are getting, please comment in the comment section. Similarly, we have submerged unit weight. Sir, the difference between saturated unit weight and submerged unit weight you should understand. If the voids are completely filled with water, then it is saturated. Submerged means it is completely immersed in water and there will be a buoyancy force here. So here gamma dash can be taken as gamma sat minus gamma W. Here gamma dash can be written as gamma sat minus gamma W. And gamma W is due to what, sir? Buoyancy force. Suppose if you take a beaker, sir, there is a cricket ball which is immersed in water. And there will be a buoyancy force here. What is the state of the soil? Is saturated. So gamma dash can be taken as gamma sat minus gamma W. Am I correct or wrong, my dear students? So this is how you calculate the submerged unit weight. But according to Archimedes principle, in some of the problems you will get, sir, if there is a beaker or anything, you have some cricket ball. Okay. Now if you immerse this cricket ball in this water, that much water will be displaced. So according to the Archimedes principle, my dear students, here you should understand that volume of water displaced. What, sir? Sir, if you are preparing for state level exams or Coal India Limited, then this session will help you a lot, sir. So volume of water displaced is equal to what, sir? Volume of solids. So here please understand, volume of water displaced is equal to volume of solids. So please write down this, students. Please write down that, sir. Done, sir? Okay. Now see, students, we have a concept called specific gravity. Sir, what is specific gravity? Specific gravity is nothing but it is the ratio of unit weight of solids to the unit weight of water. What is specific gravity, sir? It is the ratio of unit weight of solids to the unit water. So for any given soil, always remember that, sir. For any given soil, G will be constant because gamma S is constant and gamma W is also constant. Specific gravity is determined by an instrument known as pycnometer method. What is the instrument used to determine specific gravity is, or you can call it as specific gravity, or you can call it as true specific gravity, my dear students. Okay. So here, this is called specific gravity. Now, specific gravity is given by the formula W2 minus W1 upon W2 minus W1 minus of W3 minus W4. So this is how you determine the specific gravity. Now you can ask me what is W1, W2, W3. So here it is as simple as that, sir. So here if you consider, sir, all are of identical shape, to be honest. So what is W1 is weight of pycnometer. What is W1, sir? Weight of pycnometer. So what is W2? Weight of pycnometer plus solids. Yes or no? So what is W3, sir? Weight of pycnometer plus solids plus water. This is what, sir? W3. What is W4? Weight of pycnometer plus full of water. This is W4. So here, my dear students, if you want to get the specific gravity, G is equal to what, sir? As I told you. Sir, here what they are trying to do, W2 minus Ws is weight of solids. And how you got this entire denominator is how much is the water in the solids volume. That you will get in this equation. I hope you are clear, my dear students. Similarly, we have apparent specific gravity or mass specific gravity. Sir, whereas true specific gravity is always constant, when I tell about apparent or mass specific gravity, what, sir? When I talk about apparent or mass specific gravity, it is not constant, my dear student friends. Okay, why it is not constant, sir? It varies with respect to the state of the soil. So, mass specific gravity in dry state is gamma D by gamma W. Mass specific gravity in saturated state it is gamma sat by gamma W. Mass specific gravity in bulk state will be gamma by gamma W. I hope you are clear, my dear students. So please write down this, sir. So please write down this. So true specific gravity is always constant, and remember that, sir, mass specific gravity is not constant, and it will keep on changing, my dear students, and it will keep on changing. So please understand this and try to get that, because in some other questions true specific gravity is always constant, you should know, sir. Now, you name any exam without these formulas according to properties of soil. Will any exam, sir, you will see a question on this. So, what are the important formulas? Sir, there is derivation and all in our classroom things. We'll discuss everything in detail, sir. If you want to get enrolled with us, you can enroll with us. In that, we'll be discussing right from the basics and all. So, here I just want to give the overview of the things. So when I talk about the important formula, void ratio is nothing but water content into G upon SR. This is the first important formula where it is a relation between water content, specific gravity and degree of saturation, my dear students. Similarly, if you want to get gamma is given by the formula gamma W into G plus E into SR upon 1 plus E. Here, what is SR, sir? SR is known as degree of saturation. What is G? Specific gravity. What is WC? Water content. Now, if you consider gamma will become gamma sat when degree of saturation is equal to 1. So, gamma sat can be written as what, my dear students? Gamma into G plus E upon 1 plus E. Now, my dear students, if I want to know about dry unit weight, in this case, dry unit weight, you can write gamma SR as 0. So, from that formula, you will get gamma W into G plus 1 plus E, or it can also written as gamma plus gamma upon 1 plus water content. All these formulas are very, very important, my dear students. And we also have gamma is equal to what, sir? Gamma D plus SR into gamma sat minus gamma D. Okay. And here if you see, this is gamma, sir. So this is gamma D, right, my dear students? Similarly, if you have gamma D can also be written as 1 minus Na into gamma WG plus water content into G. Okay, sir. This is with respect to compaction formula you will get them. And one more thing, my dear students, you should know in a borrow pit, V2 by V1 can be written as 1 plus E2 by 1 plus E1. That is equal to gamma D1 by gamma D2. Sir, how this formula came is, just while I am explaining, you know total volume is equal to what, sir? VV plus VS. So we can write this as Vs into 1 plus E, right? So in that, for a given soil, volume of solids is constant. And gamma D is equal to what, sir? Weight of solids by total volume. And for a given soil, weight of solids is constant and gamma D is inversely proportional to the soil. And in addition to this, they can ask you, what is the extra amount of water there? Sir, what is weight of water means? How to solve? Weight of water by weight of solids is water content. So you can write weight of water is also taken as water content to weight of solids. Sir, when the word extra came, that means at that time you should find the difference in water contents. And remember, sir, gamma D is equal to dry unit weight is what, sir? Weight of solids by total volume. What is gamma D? Gamma D is nothing but weight of solids by total volume. So here weight of solids can be written as what, sir? Gamma D into volume. Am I clear or not, my dear students? Sir, usually this is one formula you have to seriously look into it. And this formula means you have to go through each and every formula. But usually in this Coal India and all, there could be questions from this side, sir. So I hope you are in a APPSC also, in a assistant executive engineer or in Transco, Genco, all those things. Even in Telangana state also. Now let us understand about the origin of soils, sir. Okay, let us discuss about index properties and then we'll talk about on. Because it's a theory part, sir, let us discuss in the latter part. So what is index properties? Sir, why do you want to study about index properties? Sir, index properties are useful for classifying and identifying the soil. Index properties are useful for what, sir? They are useful for classifying and identifying the soil. Clear, sir? Now, if you talk about, basically there are two types of soils, right? And index properties also gives you a rough estimation about the engineering properties also. So here we have fine grained soils as well as coarse grained soils, sir. Now, my dear students, if you talk about fine grained soils, which properties are helpful? One is the sedimentation analysis. For fine grain, we have a method called sedimentation analysis. And next one we have is what, sir? Atterberg. So usually these are the two methods which will help you to classify the fine grained soils. Similarly, if you want to get to classify the coarse grain, one is the sieve analysis. And other one we have is the relative density. Okay. So what is index properties, sir? Index properties are useful for classifying and identifying the soils. It gives you a rough estimation about the engineering properties of the soil. Now, my dear students, when I talk about relative density here, sir, when I talk about relative density, okay, relative density is also known as what, sir? See here, my dear students, relative density is also known as what, sir? Relative density is also known as density index. Relative density is also known as what, sir? Density index. Density index ID can be taken as what, sir? E max minus E divided by E max minus E minimum into 100. So when will be the void ratio will be maximum, sir? When will be the void ratio will be maximum? Void ratio is maximum in loose state. And when will be the void ratio will be minimum, sir? And the void ratio will be minimum in dense state. So if you consider here, it also gives you a rough estimation of the engineering properties of the soil, which is index properties. Now this relative density gives you idea about what, sir? This relative density will give you idea about what, my dear students? Can anyone tell me, sir? It gives you idea about the relative compaction also, sir. It gives you idea about the relative compaction of the soil. So here you should understand this. Sir, no, if you can remember this formula, you always remember gamma D is inversely proportional to a void ratio, you can say. More the void ratio, lesser the dry density. So here E max means, because in some questions they can give you relative density in, so E max means dry density should be minimum. E means natural state, sir. Here E max also you can write it as 1 by gamma D minimum minus 1 by gamma D maximum, because this is way if you can remember into 100. This would be easy way to remember this, sir. And remember, sir, based on relative density, you will get an idea about what? Relative compaction. Relative compaction means it is nothing but dry density in the field by maximum dry density in the laboratory. This is nothing but what, sir? Relative compaction. So when I talk about relative density here, so if you consider the state of the soil, so usually if I consider it as a table, Amma, if relative density is between 0 to 15, they can ask you these kind of questions also, sir. Very loose state. If the relative density is between 15 to 35, we call it as loose state. If the relative density is between 35 to 60, we call it as low dense. Okay. We call it as low dense. And remember, my dear students, if the relative density is 65 to 85, we call it as medium dense. And more than 85 percentile, this is everything in percentile, sir. It is highly dense. So you should understand that relative density will help you to classify the coarse grained soils and also it gives you a rough idea about the relative compaction also. Now, my dear students, let us understand what is sieve analysis. So, sieve analysis, if you see, sir, 4.75, if you consider first one is sieve size, there can be 2.36, 1.18, like that up to 2 micron. These are the standard set of sieves, sir. And in that, what we'll find? You'll find weight retained. Next, what we find, sir? Weight retained. Weight retained can be what, sir? W1, W2, W3, so on up to Wn, my dear students. Now, what we have to find out? What is the percentage weight retained? We have to find out. How to find the percentage weight retained, sir? X is equal to what, my dear students? W1 by W into 100. What is W1? What is the weight retained in that sieve to the total weight? This can be taken as X1. Similarly, X2 can be taken as W2 by W into 100. And similarly, X3 can be written as W3 by W into 100. Similarly, if I write here Xn, it can be written as what, sir? Wn by W into 100. I hope you are following, my dear students. Yes or no? So, similarly, we find out cumulative weight retained. Cumulative weight retained. So, if I take this as weight retained X1, X1 plus X2, and it can be X1 plus X2 plus X3, and cumulative here you can write it as X1 plus X2 plus so on up to Xn. So, this is what you do in cumulative weight retained. Similarly, if you want to get percentage passing, or if they used the word percentage finer, anything are same, sir. In this, it will be 100 minus X1, 100 minus of X1 plus X2. So on if I do here, 100 minus X1 plus X2 plus X3. Here it can be 100 minus of X1 plus X2, so on, Xn. So usually how will be the sieve analysis procedure? This will be the sieve analysis procedure. Any doubts, my dear students? So students, if you feel this session is helpful, share to your Andhra Pradesh Public Service Commission students who are preparing. Even for Coal India students also. Now, my dear students, let us understand some important parameters, sir, here. If a graph is drawn between percentage passing or percentage finer, and here if it is a graph drawn between percentage finer and particle size, okay, so there can be a graphs of this kind, sir. So here, what are the different types of soils we have? We consider this as well graded, this as poorly graded, or we can also call it as what, sir? Gap graded, and this is called as uniformly graded. So, my dear students, let us understand what do you mean by well graded, what do you mean by poorly graded and gap graded. Are you following, sir? So, here if I talk about well graded, what is well graded, sir, here? Sir, well graded shape, if you see, it is something like a S shape. By looking into the particles of every sizes are present here. So, usually what is well graded, sir? Its shape will be equal to S shape. So, here in well graded, particles of all sizes are present. What is well graded, sir? Particles of all sizes are present. Means, so this is very important. Similarly, poorly graded, or we can say gap graded soil. Sir, it is in the form of a hump shape. So it is form of what, sir? Hump shape. So what is poorly graded means some particle sizes are missing. What is poorly graded, sir? Some particle sizes are missing. So poorly graded or gap graded can be taken as some particle sizes are missing. Any doubts in this, sir? So next one we have is what, sir? After well graded or poorly graded, next one we have is uniformly graded. Sir, usually it will be in the form of steep slope. So here if you see, all the particles are of same size. So what is uniformly graded, sir? Particles all are of same size. So in exams they can ask you, hump shape means some particle sizes are missing. Of all the sizes are present, well graded, then it is S shape. Uniformly graded means some particle sizes are missing. So here, to understand the shape of the curve, also my dear students, let me tell you, to understand the shape of the curve also here, you should know about these things. Like there are some coefficients like coefficient of curvature, coefficient of another important thing is what, sir? Coefficient of uniformity. Just a second, students. Please write down this, sir. Any doubts, sir? Any kind of doubts, please feel free to ask me. Okay, I hope you have you. Sir, here let us understand how to find out the concept called coefficient of curvature. What is CC, sir? CC is nothing but what, sir? CC is nothing but called as coefficient of curvature. So why do you want to study about coefficient of curvature? Sir, the shape of the curve, to get an idea on the shape of the curve, we study about the coefficient of curvature. So here CC gives you an idea about what's the shape of the curve, and it is given by the formula d square 30 upon d 60 into d10, my dear students. So when I talk about CC, it gives you idea about what's the shape of the curve. Now you can ask me what is d10? D10 is nothing but the effective size. What is effective size, sir? It is the size of the sieve where 10% of the particles are passing. So please remember, sir, in some of the things they can ask you directly, what is effective size here? Sir, they can give you D30, D60, D10 something in the options. Which is effective size means D10. First of all, whether it is D30, D60, D10, whatever, D20, you should understand they are what? They are nothing but the sieve sizes. So in D30, 30% will be passing. In D60, 60% means it is the size of the sieve where there is 60% passing. It is the size of the sieve where it is 10% passing. So similarly, my dear students, you should have an idea on coefficient of uniformity. So what is coefficient of uniformity, sir? Coefficient of uniformity is all about Cu. It is defined as D60 upon D10. So why do you want to study about the coefficient of uniformity is it gives you idea about the particle size range. What, sir? D60 by D10 will give you idea about what, my dear students? It gives you idea about the particle size range, whereas CC gives you idea about the shape. So these are the two coefficients which you have to study. And remember here D10 is what, sir? D10 is nothing but the effective size. I hope you are clear, my dear students. Now let us understand the Atterberg limits, which are very important. Usually we see a lot of questions in the state level exams and all. Just a minute, students. Let me draw the diagram. Then I'll give you a complete overview of this. This is important, sir. This concept is one important. I hope you are following. Any kind of doubts, my dear student friends? If anyone is preparing for Coal India and Andhra Pradesh or Telangana state level, please share this video. Okay, here we have solids. Okay, I'll tell you what is it. This is here we have semi-solids. Here we have what, sir? This is semi-solids. And this is plastic state. And this is liquid state. These are all states of the soil. So, my dear students, we have, this is dry volume. It's a graph drawn between, basically between water volume and water content. So, this is dry volume. And this is called shrinkage limit. This we call it as plastic limit. And this we call it as liquid limit. The volume at liquid limit is VP, plastic limit because. And the volume at liquid limit is VL. So this is the thing you have to understand. Now, my dear students, there is a concept called Atterberg limits. There is a concept called what, sir? Atterberg limits, or it is also called as what, sir? Consistency limits. What are Atterberg limits or consistency limits, sir? These are the water contents. Sir, whatever shrinkage limit plastic, these are the water contents at which soil passes from one state to the other state. So what are Atterberg or consistency limit, my dear student friends? It is the water content at which soil passes from one state to the other state, right? Now, similarly, if you want to know about what is the consistency limit, it is also the Atterberg limits. So let us understand the individually. Sir, looking into the diagram, if you see a number system, 1, 2, 3, as you move towards the right, it will increase. So basically you can say liquid limit is greater than, plastic limit greater than shrinkage limit. This one important theory means some of the competitive exams you can see these questions. Now let us understand what is liquid limit. Sir, what is WL here? WL is nothing but the liquid limit. So what is liquid limit, sir? What is liquid limit, my dear students? Liquid limit is the minimum water content. It is the minimum water content at which soil has, it is the minimum water content at which soil has small shear resistance. Sir, see, if it is a liquid, it will not have any shear resistance. Then it flows like a water, right? So if it is offering some resistance, if it is like a border, sir, if you cross that border liquid limit, it behaves like a liquid. So whenever there is a liquid, it don't offers any shear resistance. So that is the reason at liquid limit, it has minimum. Or if you consider it in a practical way, sir, the cascaders apparatus, name the apparatus, they can ask you. What is the apparatus to define the liquid limit is? The apparatus which is used to define the liquid limit is nothing but the cascaders apparatus. Now, my dear students, if I consider this as a hammer blow, if you are applying 25 number of blows, it can move for a distance of 12 mm. So you will add some water into it. So that water content is nothing but called liquid limit. So what is liquid limit? Practically, sir, it is the minimum water content. So at which a soil cut by a groove of standard dimensions will flow together for a distance of 12 mm under an impact of how many blows, sir? 25 number of blows. This is the practical definition of liquid limit. And what is the apparatus used for liquid limit, sir? It is nothing but the cascaders apparatus. What is the apparatus used for determining the liquid limit is? It is nothing but the cascaders apparatus. Now, my dear students, we also have a concept called flow curve. What is flow curve, sir? So flow curve is a graph drawn between, it is a graph drawn between water content and number of blows. So usually what happens, students, here if the more the water flows, lesser the number of blows. Lesser the water, more the number of blows. So if you want to make a curve into a straight line, usually we apply logarithm, sir. Why we apply logarithm to convert into a straight line? What is log 1? 0. What is log 10? 1. Log 100? 2. So for very large values, the variation will be very small. So this is important, sir. Flow curve gives you idea about shear strength. If you are adding more water means it is a dense soil to compact. If you are adding less water means it is less. So it also gives you a rough idea. Now the slope of the flow curve. Here my dear students, you should understand. What, sir? The slope of flow curve gives you idea about what, sir? The slope of flow curve gives you is nothing but what, sir? Flow index, which is very important. Sir, in a straight line equation, what is when y is equal to mx plus c? What is m? M is nothing but here slope index. So flow index, sorry sir. Flow index can be written as W1 minus W2 upon log A minus B can be written as log of N2 by log of N1. So remember the flow index is given by the formula W1 minus W2 into log of N2 by N1. Please write down this, students. Any doubts if you are having, please ask me, sir. Any kind of doubts if you have, please ask me, students. Any kind of doubts, you are always feel free to ask me, sir. Okay, I have given you enough time, Amma. Now we have is plastic limit. What is plastic limit is, it is the minimum water content at which a soil can be rolled into 3 mm diameter without breaking. So that is nothing but plastic limit. What, sir? If we add soil into the soil, we add water into it, it is the minimum water content. If you can, soil can be made into a rope of 3 mm diameter without breaking or without crumbling. That is called plastic limit. Sir, shrinkage limit. What is shrinkage limit here is, it is the minimum water content. It is the minimum water content at which soil is fully saturated. The minimum water content at which what, sir? Soil is fully saturated. We call it as shrinkage limit. Now, my dear students, you know what, sir? E is equal to water content into G by SR. But SR will be equal to 1. And when water content is minimum, it will be equal to what, sir? Shrinkage limit. So, shrinkage limit can also be taken as the formula E by G. And one more formula for shrinkage limit is, it is given by the formula 1 by Gm minus 1 by G. Now, sir, see, by looking into the graph, up to shrinkage limit, sir, there is no change in volume. So, it is the maximum water content up to which any further loss of moisture will not cause any change in volume. What, sir? It is the maximum water content up to which any further loss of moisture will not cause any change in volume, my dear students. Any doubts in this? So, here, this is one more shrinkage limit, sir. Now, we have volumetric shrinkage. Next one we have is shrinkage ratio. What do you mean by shrinkage ratio, sir? It is the volume change. Sir, see here. By looking into it is the volume change expressed in terms of dry volume to the corresponding change in water contents. So here you can write it as shrinkage ratio as VL by minus VP upon VD, because it is the volume change expressed in terms of what, sir? Dry volume to the corresponding change in water content, or VP minus VD by VD upon WP minus WS, or you can write VL minus VD by So this is what we have, shrinkage ratio. So what is shrinkage ratio, sir? Volume change expressed in terms of dry volume to the corresponding change in water contents is nothing but what, my dear students? This is nothing but shrinkage ratio. Or shrinkage ratio can also be written as, it is the mass specific gravity in dry state, which can be written as gamma D by gamma W. Okay, gamma D by, it can be written as gamma D by gamma W. Sir, whatever the numerator part, volume change expressed in terms of dry volume, this we call it as volumetric shrinkage. What, sir? What are Atterberg limits, my dear students? These are the water contents at which soil passes from one state to the other state. Liquid state will be more than plastic state greater than shrinkage limit. What is liquid limit? It is the minimum water content at which soil has small shear resistance. What is another practical definition is, liquid limit is the minimum a soil is cut by a groove of standard dimensions, will flow together for a distance of 12 mm under an impact of 25 number of blows. Similarly, what is shrinkage limit, sir? Shrinkage limit, plastic limit. It is the minimum water content at which a soil can be rolled into 3 mm diameter without breaking. What is shrinkage limit means? It is the maximum water content up to which the soil, means any change in volume, any change in moisture will not cause any change in volume. And remember, sir, flow curve gives you idea about the flow curve gives you idea about shear strength. The slope of flow curve is nothing but flow index. Sir, I am just moving forward because I have already explained this. Okay. Now, my dear students, if you ask me, these are the important indices we have. Next we have is we have important indices. Now what is important indices? IP is equal to what, sir? Plasticity index. IP is equal to what, sir? Plasticity index. What is plasticity index? IP will be taken as WL minus WP. This is known as plasticity index. Similarly, we have shrinkage index. IS will be taken as WP minus WS. Now, my dear students, you can ask me here, when IP is equal to 0 or negative, we take it as non-plastic. When IP is 0 or negative, what we will take, sir? We take the soil as non-plastic. Now, my dear students, when IP is less than 7, we talk it as low plastic soil. Okay. When IP is between 7 to 17, we take it as medium plastic soil. When IP is more than 17, we take it as highly plastic soil. So remember this, students, when plasticity is more than, here you should understand, because if the plasticity index is, usually you should understand, if the plasticity index is negative, we take it as what, sir? We take it as, always remember, my dear students, if the plasticity index is negative, we take it as 0. That is what I want to tell you, sir, which is very important, my dear students. So please understand this. And we have shrinkage index. Similarly, we have toughness index. What is toughness index, sir? Sir, usually in one of the last year, 26 GATE, they have asked for liquidity index, sir, by giving everything. So what is toughness index means? IT is given as the formula, plasticity index upon IF. That is what, sir? That is known as flow index. So flow index is what, sir? W1 minus W2 upon log of N2 by N1. Similarly, we have liquidity index. What, sir, we have is liquidity index. What is liquidity index here? IL is equal to WL minus W minus WP upon IP. This is known as what, sir? Liquidity index. Any doubts in this, my dear students? Similarly, we have consistency index. Similarly, we have what, sir? Consistency index. What is consistency index here? Here it is IC is equal to what, sir? WL minus W upon IP. Now, my dear students, please remember, if you want to get here, IC plus IL, consistency index plus liquidity index will be equal to 100 percentile, or it will be always equal to 1. So these are the important things. And also we have activity ratio we'll be discussing in latter part, sir. Sir, if you have any doubts in these indices, these are the important indices, sir. One is plasticity index, shrinkage index, toughness index, liquidity index, and also we have the thing is called consistency index. Now, my dear students, let us understand the other important thing, that is called sedimentation analysis. So what do you mean by sedimentation analysis, sir, here? Here sedimentation analysis is based on what, my dear student friends? So sedimentation analysis is based on Stokes law. In Stokes law, sir, you will get an idea about the settling velocity. That is how much, sir? G by 18 into S minus 1. Sir, if you are preparing for state level exams or for, I mean to say, Coal India and all, this session is all for you, sir. Now here, this settling velocity can be simplified as 902 d square. If you substitute d in mm, you will get the settling velocity in mm per second. Here we have viscosity, specific gravity, what is d, sir? D is nothing but the dia of the particle size. So here we have Stokes law is valid for what, sir? It is valid for 0.2 micron to 0.2 mm. Agree, my dear students? Sir, if it is less than 0.2 micron, Brownian movement will happen. That is the reason they will not give the sizes less than 0.2 micron. If it is more than 0.2 mm, what will happen, sir? Turbulent flow will happen. So this is the reason why it is applicable for 0.2 micron to 0.2 mm. Any doubts, my dear students? Sir, students, if you feel this session is helpful for you, please try to share as much students as much you can, because it will help them if they want to quickly revise everything. Now, my dear students, let us understand the next one important part here is, what are the different methods we have? One is the hydrometer method to determine the sedimentation analysis, and we also have is the pipette method. Another one what we have, sir? We have is the pipette method. So when I talk about pipette method, so what is pipette method, sir? If I see here, pipette method is the standard method of sedimentation. What, sir? Here it is the standard method of sedimentation. Now, my dear students, if you are doing this pipette analysis or anything, if the soil contains organic matter, we have to remove that. We have to remove that organic matter. That we call it as pre-treatment. That we call it as what, sir? That we call it as pre-treatment, my dear students. So, before exposing this test, so what is pipette? You will have some solution here, right, my dear students? So, this solution we call it as dispersion solution. What is this solution, sir? This solution is called as, my dear students, what, sir? This solution is called as dispersion solution. So what is dispersion solution here is, it contains 7 grams of sodium carbonate. It contains 7 grams of sodium carbonate plus 33 grams of sodium hexametaphosphate plus 33 grams of what, sir? Sodium hexametaphosphate. So this is what? So this all will be done in what, sir? This all will be done in 1 liter of solution. So what is dispersion solution? Dispersion solution contains 7 grams of sodium carbonate and 33 grams of sodium hexametaphosphate. Now if you see the pipette method here, sir, if I see the pipette method, initially the soil particles might be here. After some time, they will be initial T1. After some time, the soil particles gets settled here, sir. So how to find out the settling velocity? The length difference between them upon the time difference. So you will get the settling velocity. So here pipette method is, this is how they will carry out. Sir, hydrometer method, you should be similar to pipette method, but corrections are important. Meniscus correction is always positive. Dispersion agent correction is always negative. So these kind of things you should remember in sedimentation analysis. Now let us understand how do you discuss the origin of soils, which is somewhat theory part, sir, and also the soil structure. But these are the things where you will get question in the state level exams. So when I talk about soil structure, origin of soils, sir, soil is derived from a Latin word. Sir, because in one of the Karnataka Public Service Commission exam, they've asked, soil is derived from a Latin word called what, sir? Solum. And what is the formation of soil process called? We call it as pedogenesis. So when I talk about the origin of soils, the first question you can ask me is, how do soils are formed? How do soils are formed? Sir, here it is a theory part. Soils are formed by weathering of rocks and decomposition of organic and inorganic matter, my dear student friends. So it is organic soils. How soils are formed, sir? Soils are formed by weathering of rocks. It can be decomposition of organic and inorganic. Sir, this is an important question here. Organic soils are called as cumulosoils. Organic soils are called as what, my dear students? Organic soils are called as cumulosoils. Agree, sir? So here when I talk about cumulus soils, example for cumulus soils is peat and humus. What is peat, sir? Half decomposite, sir. Any peat means any vegetable waste, humus, cow dung or solid waste, sir. So here this soil is formed by a cycle, sir. Soil is formed by a cycle known as what, sir? Geological cycle. Soil is formed by a cycle known as what, sir? Geological. Because geo means earth. And usually soil will be in the earth crust. So soil is formed by a cycle known as what, sir? Geological cycle. Now, when I talk about geological cycle, what are the stages of geological cycle? So students, if you feel this session is helpful for you, please share to your friends who are preparing for Andhra Pradesh Public Service or Karnataka or Coal India. So in geological cycle, we have different stages, like first stage is soil gets withered. Sir, see, weathering. And the second stage we have is transportation. And third stage we have is deposition. And fourth stage we have is upheaval. Fourth stage we have is what, sir? Upheaval. So what do you mean by weathering here, my dear students? So what do you mean by weathering, sir? Weathering can be done physically or it can be done chemically. So physical weathering is due to what, sir? It is due to the natural effects. Like, sir, in a hot summer, the rocks will break. That means due to temperature change or melting of ice, or spreading of plant roots. This happens naturally. Chemical weathering means it is due to oxidation, hydration, leaching and all. So when the soil gets withered, it gets transported, sir. It can be transported by means of air or water or any means of support. Now the soil gets deposited. Sir, here. Now what is upheaval? If you see the English meaning of upheaval, sir, it is the rise in earth crust. So soil gets deposited. A rise in earth crust is nothing but upheaval. So what are the stages in geological cycle? Weathering, transportation, deposition and upheaval. Weathering can be physical weathering and chemical weathering. Now, my dear students, there is a soil called sedimentary soils. So what are sedimentary soils, sir, here? Sir, here you should understand this. What is sedimentary soils? Soil particles created at one location. What is sedimentary soils? Soil particles created at one location and finally deposited at another location. That is known as what, sir? That is final soil particles created at one location. This is known as sedimentary soils. Now, sir, this could be your questions in your exams. Soils which are deposited in lakes, these are called as lacustrine soils. Soils which are deposited in river, these are called what, sir? Alluvial soils. Sir, see, on the banks of the river, we see lot of cultivation. So this is the reason this is called most fertile soil. What is most fertile soil, sir? Alluvial soils are the most fertile soils. Any doubts in this, students? The soils which are deposited in sea, they are called as marine soils. And sir, usually marine means efflorescence will be there. That is the reason we don't use this soil for construction purpose and all. Similarly, we have soils deposited in wind. Wind means it is a very weak soil, sir. These are called as aeolian soils. Usually they can. Example, these you find in desert summer. One is sand dunes and losses, sir. This is the most collapsible soil and we find this type of soil usually in deserts. So this is the most collapsible soil. Any doubts in these things, my dear students? So one is lakes, lacustrine, rivers, alluvial, sea, marine, wind, aeolian soils. And we also have gravitation. Gravitation, it is like usually in Himalayas or hilly areas. These are called colluvial soils. Okay, sir, these are colluvial soils. Example is talus. And we usually in Switzerland, Himalayas and all, we have the soils which are deposited due to glacier. These are called what, sir? Glacier deposited soils. These are what, sir? These are the glacier deposited soils. Example is nothing but what, sir? Drift, till. Example is what, my dear student friends? It is drift and till. So just go through this quickly, my dear students. Sir, any doubts? If you have, please ask me. Very good, sir. Let me go through it. Next one we have is what, sir? Sedimentary soils. Next one we have is all about residual soils. So what is residual soils, sir? Soils which remain on the parent rock without any transportation. What is residual soils, sir? Soils which remain on the parent rock, soils which remain on the parent rock without any transportation. This means usually, sir, black cotton soils. Usually we call example for residual soils are nothing but black cotton soils, or we can say laterite soils. The parent rock for black cotton soils is nothing but what, sir? It is nothing but basalt. Okay, it is not ballast, sir. It is basalt, my dear students. Now, see students, usually this is also another important thing I would like to tell you, my dear students. Usually if you consider gravitational forces are predominant, means more in what, sir? Gravitational forces will be more in coast drained soils. And whereas surface, electrical or chemical forces, these are more in where, sir? These are more in, whereas surface, chemical, these are more in which type of soil? These are more in fine grained soils. Agree, my dear student? Now, similarly, if you consider warwood clay. What is warwood clay, sir? It contains alternate layers of clay and silt. What is warwood clay? It contains alternate layers of clay and silt. So here, morum. Morum is what, sir? Gravel mixed with what, sir? Gravel mixed with red clay. And we also have loam. Loam means a mixture of sand, silt and clay in equal proportions. A mixture of sand, silt and clay in equal proportions is nothing but loam. So one is warwood clay, have morum, loam, and next one we have is the bentonite. What is bentonite, sir? A bentonite is decomposed by volcanic ash. It is decomposed by volcanic ash. It has high swelling and shrinkage due to the presence of a mineral called montmorillonite. So please write down this, students. I'll be back in 1 minute. Please write down that. Okay, my dear students. Let us understand soil structure, sir. Let us understand soil structure. What do you mean by soil structure, sir? Sir, you can join our Telegram group link, Amma. There I'll be posting the notes. What is soil structure? Geometrical arrangement of What is soil structure, sir? Geometrical arrangement of soil particles. Geometrical arrangement of soil particles in soil mass. So how the soil particles are arranged in a soil mass, if you want to understand, that is nothing but soil structure, sir. What is soil structure, sir? Geometrical arrangement of soil particles in a soil mass. Okay. Now, my dear students, based on the size of the soil particle, based on the size of soil particle, and how they are formed, and mode of formation. What, sir? Based on the size of soil particle and mode of formation. Okay. Soil structures are classified. Here we have sir, we have different types of structures. One is what, sir? Single grain structure. What is single grain structure means? If the soil particles are assumed as a sphere, sir, and they are arranged, array means what, sir? Cubical array. And they are arranged in a cubical array. Usually here the void ratio will be minimum, that is 0.35. Sir, it is proved also, sir. And if the voids are arranged in a cube, in a loose, here the void ratio will be maximum, it is 0.91. This is single grain structure. But next one is very important, sir. That is nothing but the honeycomb structure. How will be the honeycomb structure, sir? It will be something like earrings. Suppose we have the structure, honeycomb structure, it will be like what, sir? It will be in the form of earrings. And this type of soil is present in where, sir? It is present in fine sands. This honeycomb structure is present in where, sir? It is present in fine sands and under very small vibrations, sir. Very small vibrations, the structure will collapse. So it is a very weak in structure, sir. This honeycomb structure. Okay, now my dear students, there is another property, another structure called flocculated structure. What is flocculated structure, sir? Here, if I consider here this as the soil particles. Here we have what, sir? Here what is flocculated structure? Here we have is, this is edge, and here this is what, sir? This is face. So here, what is flocculated structure? We have here it is edge to face, here what is flocculated structure, sir? It is edge to face orientation. It has high shear strength, low compressibility, and high permeability. Sir, see, why? Due to the edge to face orientation, it is formed due to attraction, sir. When the soil particles come closer, it has high shear strength and low permeability. Why it is having high permeability? Because it is having the size of the voids more. So it is observed in which type of soils, sir? This is observed in clayey soils. Agree? Similarly, we have the last structure. That is what, sir? We have similarly what structure we have? That is called as dispersal structure. So similarly, what we have, sir? We have the final structure, which is called as dispersal structure. So what is dispersal structure, sir? So here, if I consider here, what is dispersal structure? What is dispersal structure here? Here, if you see in dispersal structure, it has here face-to-face orientation. Sir, whatever the dispersal structure is observed in which type of soil, sir? This is observed in remolded clays. This is observed in terms of where, sir? This is observed in remolded clays. Agree, students? Here it is observed where, sir? It is observed in remolded clays, and whatever the structure which is having high shear strength, low compressibility, exactly opposite nature you will find out here, sir. And one more thing, sir, there is a property called remolding. So remolding usually causes loss of strength. This you have to remember, sir. What does remolding will do? Remolding loses loss of strength. Agree, students? What does remolding will tell you, sir? What will remolding will tell? One second, sir. Just a minute. Sir, here have you written, sir? Okay, I hope you have written, sir. Soil structure have you written here? In the live group, Telegram group, they will be sharing our Telegram group link, sir. You can join. In the live chat, we'll be sharing. Soil structure, right? What is thixotropy here? What is thixotropy? Any idea, sir? Thixotropy is nothing but the phenomena of regain of lost strength, whatever the strength you have lost, the phenomena of regain of lost strength with the passage of time, with no change in water content. What, sir? The phenomena of regain of lost strength with the passage of time with no change in water content. What, sir? Here you should understand here that what, sir? The phenomena of regain of lost strength with the passage means whatever in remolding there will be loss of strength. After so whatever the lost strength you will try to regain over a period of time with no change in water content is known as thixotrophy. Similarly in clay, sir, if you see in clay, when I ask you in clay, sir, in coarse grain, in quartz, feldspar, mica will be present in gravel and sand. What are the minerals which are present in coarse grain means in gravel and sand, quartz, feldspar, some mica. In clays, we have different clay mineralogies, sir. First one we have is kaolinite. Remember, sir, it contains some gibbsite and silica. It is the most stable clay mineral. Sir, when do you say that it is the most stable clay mineral here is, if it is not exhibiting any swelling and shrinkage. Usually, when we consider stable clay mineral, example is what, sir? China clay. China clay is the best example of stable clay mineral. Agree, my dear students? So, kaolinite is nothing but the stable clay mineral. Agreed? Similarly, we have halite. This is one of the gate questions, sir. Name the clay mineral which is formed by potassium ions. Name the clay mineral which is formed by a bond between potassium ions. So here, what is the clay mineral which is formed by potassium ions, sir? That is nothing but the halite. And remember here, when I talk about halite, it exhibits medium swelling and shrinkage. Now, kaolinite behavior, if I consider another clay mineral, sir, that is halosite. Halosite mineral will be similar to kaolinite. So, halosite is also a stable clay mineral. But out of all these things, the montmorillonite, it is formed by the water molecules we have. It is formed by water molecules and it is the most unstable mineral, sir. It is the most unstable clay mineral and it exhibits very high swelling and high shrinkage. So what are the different types of clay mineralogies we have, sir? One is kaolinite, which is the most stable clay mineral. Halite, name the clay mineral which is formed by potassium ions is halite. And montmorillonite, it is having most unstable mineral. It exhibits high swelling and shrinkage. Agree, students? Now see, we have a concept called specific surface area. Sir, usually what is the surface area of rectangle? Sir, remember, surface area and area will be same will be for two-dimensional bodies. It varies with respect to only for three-dimensional. So what is specific surface area means? It is the surface area of specific surface area is what, sir? It is the surface area of soil particles. What is specific surface area? It is the surface area of soil particles present in the surface area of soil particles present in unit weight. This is known as what, sir? Specific surface area. Sir, usually the units will be centimeter per gram. Usually sir, here this is very, very important. One of the important objective questions, sir. Finer the soil, higher the specific surface area. So if you consider colloids will have more than clay, clay will have more than silt, silt will be more than sand, and sand will be more than gravel. This will be usually the order, my dear students. Similarly, we also have another concept called diffuse double layer. Similarly, we have a concept called what, sir? Diffuse double layer. Sir, usually in ground improvement technique, we use this. I'm just giving a overview of this, sir. Sir, see, usually the shape of the clay particle is angular or flaky. Sir, this is called rigid layer, and we have this is called the loose layer. So what this we call it as what, sir? This we call it as limit of attraction. So what is diffuse double layer, sir? The layer on the clay surface up to limit of attraction. What, sir? The layer on the clay surface up to limit of attraction due to electrical forces is known as what, sir? Diffuse double layer. Whatever the water which is held in this zone, that we call it as adsorbed water. Sir, the layer on the clay surface up to limit of attraction, sir, that is called diffuse double layer. Whatever the water which is held in this zone, this is known as adsorbed water. Now, this adsorbed water will create what, sir? Plasticity. So, plasticity is a dangerous property. So, to remove, so instead of adsorbed water, if you add kerosene, which is a non-polar liquid, what, sir? Kerosene being a non-polar liquid, it will not cause any plasticity to clay. So, see students, I hope you are clear. So, let us have a quick 15-minute break, sir. And we'll continue in 15 minutes. Okay. So my dear students, let us understand. Until now we have discussed about properties, soil structure, origin and index properties. Let us discuss soil classification. Sir, when I talk about soil classification here, based on the size of the soil particle, what sir? Based on size of soil particle, soils are classified. Here if you see, we have different sizes. If it is 2 micron, we call it as clay. 2 micron to 2 micron, we can call it as clay. Less than 72 micron to 75 micron, we call it as silt. 75 to 0.425 mm, we call it as fine sand. 4.42 to 2 mm, we call it as medium sand. And 2 mm to 4.75 mm, we call it as coarse sand. So 75 micron to here, we call it as what sir? Sand. So more than 4.75 to 80 mm, we call it as gravel. 80 mm to 300 mm, what we call sir? We call it as, are you following students? So if you are interested, please share with your friends sir, who are preparing for Andhra Pradesh State Service Commission, or more than 300 mm, we call it as boulder for Coal India. So based on the size of the particle, we have clay, silt, sand, fine sand, coarse sand, medium sand, gravel, cobble and boulder. These are the things. So now my dear students, there are some organizations like ASHTO, HRB and PRA. So what is ASHTO? American Association State Highways Transport Officials. HRB, Highway Research Board. And we have is PRA, Public Road Transportation. So all these organizations are related to what sir? Related to roads. So what is their intention is, they want to identify the soil which is suitable for pavement. So the soil is classified into 7 groups. A1, A2, A2, A7. So here understand my dear students, smaller the number, better is the soil. Okay sir. And black cotton soil fall under which group sir? A7, which is having high swelling and shrinkage. So based on the size of the soil particle, we have clay, silt and these are all sand, and here we have boulder, cobble and everything. Now my dear students, see here. There is another important thing called group index. So what is group index here is, it is used to indicate the quality of the soil. It is used to indicate the quality of the soil within the same group. Sir, what is group index? It is used to indicate the quality of soil within the same group. Okay. Within the same group. Sir, there is a huge formula which is not required, but this group index is depending on what sir? It depends upon percentage of soil passing through. 75 micron passing through. Next, plasticity characteristics or plasticity index you can say, and it depends upon liquidity index. Okay, plasticity characteristics, and it also depends upon liquid limit, plastic limit and all. So here also my dear students, group index varies between 0 to 20. Here also group index varies between what and what sir? 0 to 20. Here you should understand that smaller the group index, here also you should understand, smaller the group index, better is the soil for pavement. What sir? Smaller the group index, better is the soil for what sir? Better is the soil for pavement. You should always remember this students. So smaller the group index, what is this thing sir? Better is the soil for pavement. I hope you are following. So here now my dear students, there are some soil classification system. First we have is what sir? Unified soil classification system. First we have is what sir? unified soil classification system. What is unified soil classification system? Sir, what is unified soil classification system is, it is based on particle size distribution, or we call it as grain size distribution. Uniform soil classification depends on what, sir? It depends upon particle size distribution. Okay. And it depends upon plasticity characteristics. It depends also on plasticity characteristics. And it depends upon compressibility. And it also depends upon what, sir? Compressibility. You should understand this, sir. So here what do you have to understand? Unified soil classification distance upon plasticity characteristics, compressibility and particle size distribution. Based on this, the soil classification is done, sir. And who is discovered this system, if you ask me? Casgradus has discovered this system, sir. Who has discovered this system? Casgradus apparatus has done this, discovered this system. Now, my dear students, if you considered Indian standard soil classification system, what, sir? If we considered Indian standard soil classification system, it is derived from unified soil classification system. So it also depends on same properties, sir. So it also depends on the same properties like particle size, plasticity characteristics and all. Here the soil is classified into how many groups, my dear students? Here also the soil is classified into 18 groups. So please write down this, my dear students. So students, if you feel that this is helping you, you can share with your friends and all, so that it will help them. Any doubts, sir, in this? Okay. Now, my dear students, if you represent clay, clay is represented as with the symbol C. Sand is represented as S. And here silt is represented as M. Gravel is represented as with a symbol G. And organic soil is represented by a symbol called O. So, my dear students, if you tell that this is well-graded gravel, when I used the word well-graded gravel, sir, first of all, what is the kind of the soil we have? First of all, you should understand what is the type of the soil. It is gravel, right, sir? So, when they used well-graded gravel, it is represented as GW. Well-graded gravel will be represented as what, sir? GW. Similarly, if I tell you poorly graded sand, what, sir? If I show you it is as a poorly graded sand. What is poorly graded sand, sir? It is represented as SP. So first of all, here in this soil classification, the soil type will be given highest priority. Now similarly, my dear students, here you can ask me another important thing, sir. Suppose if they give you silty sand. Sir, if the word comes like this, as you move towards the right, what it happens here is sand composition will be more than silt. You should understand what, sir? Sand composition will be more than what, sir? Sand composition will be more than what, my dear students? Sand composition will be more than the silt composition. You should understand this, everyone, my dear students. So here silt, first sand is more, so S, after that silt. This you should always remember, my dear students. I hope you are clear. Okay. Similarly, they can give you silty clayey soil also. Sir, silty clayey soil if they give you, students, or silty clayey sand. So here also you should understand that as sand composition will be more than clay and clay composition will be more than silt. Sir, always weight in soil classification, weight composition will be given the highest priority. That please keep this in mind, students. Now we have an important property called plasticity chart. What, sir? Plasticity chart. So before discussing plasticity chart, sir, based on the liquid limit, whether it is low compressible, intermediate compressible or highly compressible, so students who are interested, they can join our Telegram group link also. So if liquid limit is less than or equal to 35, if liquid limit is less than or equal to 35, we call it as low compressible soil. If liquid limit is less than or equal to 35, we call it as what, sir? Low compressible. If liquid limit is between 35 to 50, we call it as what, sir? Intermediate compressible. So based on the liquid limit, we will understand whether it is intermediate compressible or highly compressible. And remember, if liquid limit is more than 50, if liquid limit is more than 50, we call it as highly compressible, students. We call it as what, sir? Highly compressible soil. So here these are the things based on the liquid limit. We have low compressible, intermediate compressible and highly compressible. Now see, students, how will be the liquidity? See, plasticity chart and all. Now, what is plasticity chart means? It is a graph drawn between plasticity index and liquid limit, sir. Here we have, this is called 20. Here it is 35. Here it is 50. Sir, above A line, usually it is represented as clay. So if it is less than 35, we call it as low compressible. 35 to 50, it is intermediate. And more than 50, highly compressible clay. So below A line, it can be organic soil or silty soil. So here it is OI, intermediate organic soil, intermediate silt, or you can write here OL or ML. Now, here if I talk about when the liquidity, see, when the plasticity index is between 4 to 7, the soil will have dual nature of clay and both silt. And here it will be around 10 and 20. So what is this? This is nothing but the plasticity chart, sir. Here, this we call it as what? This we call it as A line. So how do you get the equation of A line? Let me tell you. How do you get the equation of A line? Sir, here A line equation is given by the formula IP is equal to what, sir? 0.73 into WL minus 20. So this is nothing but the equation of A line. So for suppose if they have given you, example, liquid limit is given as 40, plastic limit is given as 20. Classify the soil. They can ask you like this, sir. They can ask you classify the soil. Now from A line equation, if you calculate IP, what it is this, sir? 0.73 into WL minus 20. Here WL is how much, sir? If I substitute it as 40, 20, you will get 14.66. Right, sir? You will get a value of 14.66. But if you calculate IP, can also be written as WL minus WP, which is 20. So here your A line is at where, sir? 14.66. What is the formula you got? IP, WL minus WP, 20. 20 is above or below? It is above. So it is clay. Now what is the liquid limit? Liquid limit is between 35 to 50 because it is 40. Right, sir? So the answer here will be intermediate clay. So the answer here will be what, sir? Intermediate clay. So in this way you should be aware of this, sir. Now see, students, when the fines are less than 5 percentile, you always talk about well graded or poorly graded. Similarly, if the fines are more than 12 percentile, you talk about silty gravel or clayey gravel or clayey sand, means you have to talk about the clayey nature or silty nature. So see, this is an important thing, sir. Fines based on the fines ratio. And see here, if IP value is between 4 to 7, what you have to do, sir? You have to talk about the dual nature. If IP value is between 4 to 7, what you will find out? You will find the dual nature. Now, similarly, my dear students, there is a concept called activity ratio. Sir, before moving to activity ratio, you can ask me, sir, how do you differentiate silt and organic soils? Sir, for organic soils, we have a separate, for organic soils, we have separate tests. If you consider here the color of organic soil, it will be dark gray or brownish color. What, sir? For organic soils, it will be dark gray or brownish color. Similarly, if you see the order, it will be bad order. It will be what, sir? Bad order. And remember, my dear students, the liquid limit after oven drying. If you consider here liquid limit, the liquid limit after oven drying reduces by more than 20%. If the liquid limit after oven drying reduces by more than 20%, then we call it as what, sir? Organic soil. So these are the, but this is the step which is important, sir, for to distinguish organic soil and silt. Agree, my dear students? I hope you are clear. Okay, now see students, if you ask me, there is a concept called activity ratio. What is activity ratio, sir? It is nothing but the activity ratio is given by the formula IP upon percentile C. So what is IP, sir, here? IP is nothing but the plasticity index. What is IP here? IP is nothing but what, students? It is nothing but the plasticity index. And percentile C is nothing but the clay fraction. What is percentile C? Sir, they can give you in the something like this. Why do you want to study about activity ratio? Sir, to understand the swelling is nothing but bulging, sir. The swelling and shrinkage characteristics of a soil are represented by a number called activity number. So if they give you something like silty clayey soil, that means if they give you silt content as 30, then clay content will be 70. If you should not take silt content as 30 in the formula. And one more thing, sir, if activity ratio is less than 0.75, it is low active. If the activity ratio is between 0.75 to 1.25, we call it as medium active. If the activity ratio is more than 1.25, we call it as highly active. So here you should be aware of these things when you are doing the activity ratio. So my dear students, let us understand the very important topic in soil, especially for GATE, sir. But in state level exams also, it is a Coal India or APPSC, it will be also helpful, sir. So what is permeability? Sir, if there is a tank, if there is a pipe, sir, if you close the wall, water will not flow. If you open the wall, water will flow. So the water flowing capacity in the soil is nothing but what, sir? Permeability. What is permeability, sir? The water flowing capacity in soil is nothing but what we call it as permeability. Agree, sir? Now, my dear students, a soil has highly permeable. When do you say that a soil is highly permeable, sir? A soil is said to be highly permeable if it has continuous voids. If the voids are continuous, we say that soil is having highly permeable. Agree, sir? Similarly, when do you say that a soil is low permeable? When do you say that a soil is low permeable, sir? If it has discontinuous voids. A soil is said to be highly permeable if it has continuous voids, and a soil is said to be low permeable if it has discontinuous voids. Agree, my dear students? Now, according to Darcy's law, if I consider according to Darcy's law, What does Darcy's law says, sir? Velocity is proportional to hydraulic gradient. So what is hydraulic gradient here is, it is nothing but the loss of head per unit length. So according to Darcy's law, velocity is proportional to hydraulic gradient and it is applicable only for laminar flow. So V can be written as some I into K. Sir, hydraulic gradient doesn't have units. So K units will be same as velocity units, which will be centimeter per second, or K is also called as coefficient of permeability. What is K, sir? K is also known as coefficient of permeability. Agree? Now remember, sir, what are the factors affecting permeability if you ask me? K is equal to, given by the formula, D square C into E cube by 1 plus E into gamma W by mu. So this is the formula for permeability, sir. So here what you have to understand, permeability is proportional to D10 square. So here what you have to do, more the effective size. What we have to do, sir? Effective size is more. Okay, if the effective size increases, permeability also increases. That you have to keep always in mind. What is effective size, sir? It is the size of the sea where 10% of the soil particles is passing. See students, if you feel this session is helpful for you, you can share with your friends. Next, what is C we have? C is nothing but what, sir? C is nothing but shape constant. So what is shape constant here is, rounded particles are more permeable. You can write here. You can write here. Rounded particles are more permeable. Rounded particles are more permeable compared to, because the size of the voids compared to angular particles. You can say in rounded particles, the voids will be continuous. Whereas in angular particles, the voids will be discontinuous. Now, by looking into the equation, sir, you can say K is proportional to E square. That means, but this assumption is wrong, sir. Actually, by looking into the equation, you will see that void ratio more, permeability more. But that is wrong. Okay, void ratio increases, sorry, permeability increases with a decrease in void ratio. You should remember this. So permeability is inversely proportional to void ratio. That is the reason permeability will be less in fine grained soils, and because permeability depends upon the fine grained soils. Now see students, here permeability depends upon viscosity. Sir, if you pour some oil, it will take more time to scatter. But if you pour water, it will be easily scattering. So here what I would like to tell you is, permeability increases when increases with increase in temperature with a decrease in viscosity. With a decrease in what, sir? Viscosity. This is very important, sir. I hope you are clear, my dear students. Next one, what we have is, seepage velocity is given by the formula velocity upon porosity. And porosity, if you see the range, my dear students, the range of porosity will be 0 and less than 1. So you can always remember that seepage velocity is always greater than the actual velocity. Am I clear, sir? Next one we have. Sir, here we have discussed about the factors affecting permeability, and you should remember that seepage velocity is velocity upon porosity, and seepage velocity is greater than what, sir? The actual velocity. Any doubts in this? Okay. Now see, sir, what are the tests to determine permeability? Now, my dear students, if you ask me what is the instrument used for determining the permeability is permeameter. But we have different tests. So in this we have, first one we have is the constant head test. What's our first one we have is constant head test. In the name itself, it is constant. So when you kept head constant, what's sir? When you kept head constant, keep the head constant and discharge is measured. Okay, sir. Here the head is kept constant and discharge is measured, sir. So you should say that constant head test is suitable for which type of soils? It is suitable for coarse grain, and Q is equal to AIK. So here you should understand discharge is equal to what, sir? AIK. This is the constant head test. Similarly, variable head test. Similarly, what we have, sir? Variable head test, or this is also called as falling head test. Sir, see, when I talk about variable head test or falling head test, this is suitable for what, sir? This variable head test or falling head test is suitable for fine grained soils. You can ask me why it is not applicable for, why constant head test is not applicable for fine grained soils is, sir, fine grained soils settle by settling velocity and they keep on changing the head. So it is very difficult to maintain the head constant in case of fine grained soils. So here variable head test is given by the formula AL by AT into ln of H1 by H2. So here if you can ask me what is area, sir? Area of the standard pipe, L is nothing but the standard pipe. A and capital L are the area and length of the area and length of the soil sample. T is the time for the head falling from H1 to H2. So this is what about variable head test. And we also have similarly consolidation test data which is suitable for clays, sir. And we also have capillarity test also. We have pumping in test. Sir, usually pumping in test with the principle of permeability, it is useful for testing of rocks, students. Similarly, we have pumping out test. Pumping out test is done in large engineering projects, my dear students. Pumping out test is done for what, sir? It is done for large engineering projects. Am I clear or not? See, students. Now, sir, permeability in a horizontal flow. Sir, next one we have is what, sir? Permeability in horizontal flow. What do you mean by permeability in a horizontal flow means? So here is the permeability which is flowing, sir. Okay, if you say in a permeability in a horizontal flow, you should understand that discharge will be equal to the summation. It can be n layers. Head loss will be same. Sir, these two equations you should remember even though you remember the formula. So in the horizontal flow, KH is given by the formula sigma I is equal to 1 to n Zi Ki upon sigma I is equal to 1 to n Zi. This is called what, sir? This is known as the horizontal flow. Similarly, if I considered vertical flow, sir, when they told parallel flow or horizontal flow or series flow, parallel flow, usually this. Now, permeability in vertical flow or you can say perpendicular flow. Permeability in vertical flow or you can say perpendicular flow. That means I am not drawing the complete diagram, sir, here. The water will be entering in this way. Perpendicular, right? So here what happens, my dear students? Here discharge will be constant. In the permanent, discharge will be constant. Head loss will be summation. In this case, what, sir? Head loss will be summation. Am I clear, sir? So in this case, if you want to find out the vertical flow, this will be sigma I is equal to 1 to n Zi divided by sigma I is equal to 1 to n Zi Ki. So this is nothing but the vertical flow. Always remember, sir, practically if you take the values, mathematically we can prove, sir, horizontal flow is always greater than vertical flow and equivalent permeability is given by the formula sigma Kh into Kv. Equivalent permeability is given by this formula. I hope you are clear with the permeability concept. Now see, students, let us understand compaction. So what is compaction, sir? See, if you consider here a soil mass, if I consider here a soil mass, students, okay, in this there will be what, sir? There can be water or there can be water or there can be air. So if you consider removal of both air and water, if you remove air and water, I hope you are following, students. So if you join our Telegram group, sir, you can get all the notes of today's class. So if you remove air and water, then you will remove what, sir? Then it is called what, sir? Compressibility. If you remove only water, then it is called what, sir? Consolidation, which is a separate topic which we'll be discussing in the later class. So here, what is compaction? What is compaction, sir? Here you should understand compaction is nothing but it is the removal of air. Compaction is nothing but what, sir? It is the removal of air from voids. Compaction is nothing but the removal of voids from air. Sorry, it is the removal of air from voids under short-term moving vibrating loads. So you do damping and all, sir, under short-term moving vibrating loads. Now, my dear students, you can ask me, sir, if you do compaction, what will happen, sir? If you do compaction, what will happen? It improves strength of the soil. Okay, basically it improves shear strength. Thereby it will improve what, sir? Strength of the soil. Now we have different tests. Sir, compaction tests we have. Why do they do compaction tests? Sir, they do compaction tests to determine what, my dear students? To determine OMC. OMC means what, sir? Optimum moisture content. And compaction tests are also done to determine the amount of compaction. Amount of compaction is nothing but what, sir? It is nothing but the dry density. So here, if you consider what are the two tests if we have, first one we have is the Indian Standard Lightweight Test. What, sir? First one we have is what, my dear students? First one we have is the Indian Standard Lightweight Test, and this test is also called as Standard Proctor Test. What, my dear students? Indian Standard Lightweight Test is also called as what, my dear students? This is also called as Standard Proctor Test. So what is Standard Proctor Test? Let me tell you. Here soil is arranged in how many layers, sir? 3 layers. Here soil is arranged in how many layers, my dear students? Here it is arranged in 3 layers. And how many number of blows are given? 25 number of blows. And here volume is how much, sir? Here volume is given as 1 liter, or it is taken as how much, sir? 1000 ml, or we can say 1000 centimeter cube. So volume can be taken as 1000 ml or 1000 centimeter cube or 1 layer. And each layer is given as 25. And here the height of fall, if you see, here hammer weight will be there, because in some exams they can ask you these questions. 2.60 kg and also height of fall. Sir, compared to if they ask you at what height the hammer will fall, that will be 31 centimeter, or you can say 0.3 mm. Sir, compared to effortness means how much energy you are doing in this test. That energy will be taken as potential energy, sir. Mass is how much? 2.6 kg. Number of G is 9.81. Height is 0.31. But there are 3 layers and 25 number of blows. If you solve this, the compared to effortness will be taken as how much, sir? 5. If you do this calculation, you will get a value of 593.01 Newton meter. I hope you are clear. Similarly, I hope you are written this, students. Means as I told you, if you can join our group, you'll get all the notes and all from this session. And we have Indian Standard Heavyweight Test. Next one, what we have, sir? Indian Standard Heavyweight Test. So Indian Standard Heavyweight Test is also known as what, sir? This is known as Modified Proctor Test. Sir, what is this Indian Standard Heavyweight Test? This Indian Standard Heavyweight Test is also called as what, sir? Modified Proctor Test. So here, if you consider here, soil is arranged in how many layers? Soil is arranged in 5 layers. And hammer weight is how much, my dear students, here? Hammer weight, if you consider here, hammer weight is 4.90 kg. Hammer weight is 4.90 kg. Height of fall, if you consider here, height of fall, if I consider 45 centimeter. So if you consider here, soil is arranged in 5 layers, hammer weight 4.9. Now here also volume also 1 liter, sir. So if you do here compared to effortness, here mass is how much? 4.9, 9.8 gravity, height of fall is 0.45, but 5 layers and 25 number of blows. So if you solve this, you will get a value of 2703.88 Newton meter. If you can check it, sir. Okay, now that question they can ask you here is the comparative effectiveness of standard Proctor test. Don't remember standard penetration test, sir. You will be confused. Is 4.55 times the modified Proctor test. Comparative effectiveness of modified Proctor test is 4.55 times the comparative effectiveness of standard Proctor test. You should remember this, students. Now see, students, you can ask me, sir, in the present days in the field, everyone is using Indian standard heavyweight test, and that too they are using modified Proctor, means compared. Now if you see, usually lightweight test, if you see, sir, if you see here, students, when I talk about lightweight test or Proctor test, this is used for ordinary highways. But when I talk about Indian standard heavyweight test, sir, this is applicable. When I talk about Indian standard heavyweight test, where it is applicable, sir? It is applicable for express highways. This is applicable for what, sir? Express highways. And this is also applicable for what, sir? Airport runways. This is also applicable for what, students? This is also applicable for airport runways. So Indian standard heavyweight test, are you following, my dear students? Sir, sorry, TGP. Sai PSPK, TGPSC AW use the sir. 100% amma Sai, it will 100% it will be helpful for your TGPSC also. That is the reason I have shared. In the thumbnail, it is not only for Andhra, sir. It can be done for all the state levels. And APPSC also you can do that, amma. So for any state level, I told you Coal India, all these things you can easily do, sir. Any doubts in this? So please write down here the comparative effectiveness of modified Proctor test is what, sir? It is 4.55 times the standard Proctor test. Agree, students? Any doubts in this? So here what I would like to tell you here is, sir, see, these applications, lightweight test, heavyweight test, you are aware already. So here let us understand how the factors affecting the water compaction. Now see, students, if I see about the factors affecting the compaction here, a graph is drawn between what, sir? Here if you see here, a graph is drawn between dry density and water content. So here we have these are the different types of water contents we have. Now my dear students, see, you have to understand this, we call it as modified Proctor test, and this is not standard Proctor. This is standard Proctor test. Don't confuse with standard penetration test. See, student. So when I talk about standard Proctor test here, sir, see, the water content here, what is this, sir? This is called as maximum dry density. And here this is also what, sir? This is also maximum dry density. And here this is what? OMC. This is also OMC. This we call it as what, sir? Zero air void line, my dear students. Now you can ask me, what is modified Proctor test here? So here MPT is nothing but what, sir? This is nothing but, we are talking about factors, no? So before talking about the factors, here let me discuss what is OMC, sir. What is OMC, sir? OMC is nothing but the optimum moisture content. What is OMC here? OMC is nothing but the optimum moisture content. What is optimum moisture content, sir? It is the water content at which, by looking into this diagram, it is the water content at which dry density is maximum. That is known as optimum moisture content. Now in this, through the diagram, students, if you consider what are the factors affecting the compaction, first one we have is the water content. So here if you see, as water content is increasing, dry density is increasing, reaching a maximum value and then decreasing. So as water content increases, dry density increases, reaches a maximum value, and then dry density decreases. This you should be aware. the second important point here, what we have, sir? Sir, here, this is another important thing. Type of the soil. But I will be happy if you tell me from the statement, sir. Sir, when I talk about the type of the soil here, you should understand that pure sands don't have a well-defined OMC. What, sir? Pure sands don't have a well-defined OMC. Sir, basically, if you know the English, what does this mean actually? Pure sands don't have well-defined OMC. So, if I draw a graph between dry density and water content, sir, the graph from the table will come like this. So, you cannot plot where exactly the dry density is maximum. So, that is called the pure sands don't have well-defined OMC. Next important thing is compactive effectiveness. Sir, as I told you, compactive effectiveness increases, dry density increases, and obviously amount of compaction will be increased. And one more important point I would like to tell you here, students, whether it is a modified Proctor test or a standard Proctor test, volume is how much, sir? 1 liter. Suppose this you can write it as a note or a practical application, sir. What is the note here is, if the percentage of soil retained on 4.75 mm. What, sir? If the percentage of soil retained on 4.75 mm is more than 20%. What, sir? If the percentage of soil retained on 4.75 mm is more than 20%, then the practical application you should remember here is the mold volume should be increased to 2.25 liters and the number of blows will be increased from 25 to 56. Sir, usually when you are going in a practical way of thinking, then this is very important. So usually means when the percentage of soil retained on 4.75 mm is more than 20% means what, sir? The size of the soil particle is increasing. So when the size increases, volume also increases from 1 liter to 2.25 and number of blows will be increased from 25 to 56. I hope you are understanding, my dear students. So let us go through the, sir, see, there are some things like relative compaction, which I told you in relative density. So what is relative density means? Sorry, relative compaction means, just I want to tell you because, so through relative compaction, you will get an idea how the soil layers are compacted. So relative compaction is what, sir? It is nothing but the dry density in the field by maximum dry density in the laboratory. This is nothing but the relative density. Sir, as I told you, if you multiply with 100, then it is percentage. If you are not multiplying with 100, then it is not percentage. So this is what? Relative compaction. Now similarly, we have a test called standard Proctor test. We have a test called what, sir? Standard Proctor test. What is the standard Proctor test is, a needle is pushed into the soil. What, sir? A needle is pushed into the soil for a depth of 7.5 centimeters. Now, if the needle is penetrating very easily, you can understand, my dear student friends, that indicates it's a loose soil. If the needle is offering some resistance, then it is a hard soil. So this is a basic immediate test where you can get an idea on compaction. What is standard Proctor test, my dear students? Here the soil is, means a Proctor needle is pushed into the soil and the resistance offered by it is measured. So this is all about the relative compaction. Now let us understand what are the equipments used for compaction. So here if I talk about the equipments, my dear students, first one we have is the vibrators. So if you try to use the vibrators, these are useful for the compaction of what, sir? Sands. Similarly, my dear students, if you are using sheep foot rollers, what, sir? If you are using sheep foot rollers, these are used for compaction of what, sir? Cohesive soils. What are cohesive soils? A clayey soil is nothing but a cohesive soil. Now similarly, if you talk about pneumatic rollers, if I talk about what, sir? Pneumatic rollers, these are useful for cohesive as well as cohesionless. Sir, remember always, Cohesionless soils are nothing but gravel and sand. Sir, cohesion in a better understanding way is nothing but bond, in a simpler way of understanding. Now, my dear students, you have discussed what are the equipments required for compaction. So, let us understand the final thing which is very important. Sir, this is a very important terms. One is the dry off optimum and another one is what, sir? Wet off optimum. I hope you are following, my dear students. So when I talk about dry off optimum, the word dry means what, sir? The how much water is required for OMC. So you see here, my dear students, here what is modified means what is OMC? The water content at which the dry density is maximum. So if the water is less than the water required for OMC, then we call it as dry off optimum. If the water content is more than the amount of water required for OMC, then it is wet off optimum. So here when I talk about dry off optimum, it has more swelling and at the same time more shear strength. As it is having more swelling, it will be used for outer shell. If you see wet off optimum, it has less swelling, so it will be used for core of earthen dams. So these are the practical applications for compaction, my dear students. Next, we have next topic is related to effective stress. So before discussing about the effective stress, my dear students, I hope you are following, sir. Any doubts if you have, please ask me. Suppose if you have considered a soil particles here, and whatever the load which is taken by the soil and also by the water, then it is called what, sir? Total stress. Then it is what, sir? Then it is called as a total stress. Sir, always remember total stress will be written as effective stress plus pore water pressure. Sir, now see what is effective stress. Effective stress is nothing but the intergranular pressure between the, it is the intergranular pressure between soil particles only. The intergranular pressure between what, sir? Between soil particles only. We call it as what, sir? We call it as effective stress. Similarly, what is U, sir? U is nothing but the pore water pressure. U is nothing but what, sir? This is nothing but the pore water pressure. So here you should understand this. Okay. Now remember, effective stress cannot be calculated directly, sir. By measuring the pore water pressure and total stress, then only you can measure. So if you talk about the whether you consider it to define the soil properties, whether you take total stress or effective stress into consideration, then you always have to remember that effective stress will be taken into consideration. Because to tell the bearing capacity of the soil or to talk about the shear strength of the soil, actually this effective stress makes a huge difference. Now U is taken as pore water pressure, or it is also called as neutral pressure. Why it is called neutral pressure? Because it does not influence any of the engineering properties of the soil. Agree, my dear students? So here we have different cases. What are the different cases of soil? So if I talk about here, if this is the depth of the soil Z and we have gamma as unit weight. So here there is no unit weight. So the total stress will be taken as gamma into Z. Sir, how this formula came, you are already aware. What is stress, sir? Stress is nothing but weight upon area. But what is gamma? Gamma is nothing but weight by volume. Gamma can be written, weight can be written as what, sir? Gamma into volume. Volume can be written as area into some depth Z. So if I plug in this gamma A into Z, you will get finally gamma into Z. So my dear students, here effective stress will be also gamma Z only. This is effective stress. So what is the statement here I want to tell you here is, total stress will be equal to effective stress when there is no water table. So this is what you have to learn in the point. When there is no water table, total stress will be equal to what, sir? Effective stress. Am I clear, sir? Similarly, in the case B, if I consider here soil strata as Z, and if I consider this as a surcharge loading, Okay, now the stress will be uniform throughout the things. So it will be Q, Q. So what you have to remember here is, in case of surcharge, what my dear students, in case of surcharge, the stress will be uniform. What sir? In case of surcharge, stress will be uniform. Please keep these things in mind, my dear students. Now see, case 3. If you have some water table, so what will be the condition of the soil, sir? It will be saturated, right? Now, if I consider here total stress will be taken as what, sir? It will be taken as gamma sat into Z. What will be the pore water pressure? It will be gamma W into Z. This is total stress. Now, total stress minus effective stress will be gamma dash into Z. This is effective stress. So, what you have to remember, my dear students, in the calculation of effective stress, gamma sat will be replaced by gamma dash. Right, my dear students? Any doubts in this, sir? Similarly, if the soil is having different Z1 and Z2 with different soil strata, it is having gamma 1 and gamma 2, then it will have gamma 1 Z1 and this will be gamma 1 Z1 plus gamma 2 Z2. So, when a soil is having different soil stratas, you should understand that when a soil is having different strata, you should understand here that slope changes. What, sir? Here, slope changes. Okay, sir. I hope you are clear. Next. When I talk about the water, sir, when I talk about effective stress in water, there are different types of water. One is capillarity water. Another one we have is structural water. Another one we have is adsorbed water. Now, my dear students, what is adsorbed water? Sir, what is adsorbed water? The water held in the zone of diffuse double layer is known as what, sir? Adsorbed water. And remember, this adsorbed water will create plasticity. Now, what is structural water, sir? It is an integral part of the soil. It cannot be removed by ordinary woven drying. So, structural water, okay, it cannot be removed by woven drying. This is important. Capillarity water. What is meant by capillarity, sir? The rise or fall of a liquid is known as capillarity. What, sir? First of all, you should understand what is capillarity. The rise or fall of a liquid. The rise or fall of a liquid is known as what, sir? Capillarity. Now see here. Now here what I want to tell you is the interconnected voids will act like what, sir? Will act like a capillarity tube through which the water may rise or fall. This is called capillarity fringe. This is, we call it as what, sir? Capillarity fringe. Now see, sir, the capillarity water will be under tension and this water will cause compression to the soil mass. This water will be causing what, sir? This water will be causing compression to soil mass. Now, the last topic for today, sir, which is important, that is consolidation. What is the last topic we are taking, sir? We are taking as consolidation into account. Sir, as I told you, what is compaction? Removal of air. What is consolidation means? It is the removal of water from voids. It is the removal of water from voids. So what is consolidation? It is the removal of water from voids under a steady static long-term pressure. Sir, what is consolidation? It is the removal of water from a voids under a steady static long-term pressure. Sir, if you see Leaning Tower of Pisa, that is the major culprit for Leaning Tower of Pisa is nothing but consolidation. Okay, sir. Now see students, when I talk about this consolidation, because consolidation happens beneath the structure, that is under, are you getting me, sir? Consolidation happens beneath the structure means it happens in substructure. So here Terjagi has given one standard model, sir, to understand this, that we call it as spring analogy model. So what is this spring analogy model means? If I consider this as all the springs, those soil springs are, these are as soil springs, and this is the water, sir. And we have, this is what, sir, surcharge loading. And here we have wall. What is wall, sir? If you open the wall, water will flow. If you close the wall, water will not flow. So wall is known as, if you see in practically, this is permeability. If you consider spring, spring is considered as soil grains, and the cylinder is considered as voids. The stress on water is pore water pressure, stress on spring is effective stress. Agree, my dear student? Similarly, in consolidation, sir, in consolidation, we have different stages of consolidation. One is the initial consolidation we have. Next one we have is the primary consolidation we have. And next one we have is the secondary consolidation we have. So when I talk about the initial consolidation, even though the definition of consolidation says that it is the removal of water, initial consolidation happens in partially saturated soils. Just if you apply the load, the air will be removed. Primary consolidation is due to the removal of water. Secondary consolidation occurs only after primary consolidation. And remember, secondary consolidation occurs at constant effective stress, sir. And it is the removal of highly viscous water. After remove that highly viscous water, either soil particles will come closer or there will be some readjustment of soil particles. Got it, sir? Clear? And this secondary consolidation occurs only after primary consolidation. Clear, students? Any doubts in this? Now see, there is a concept called AV. What do you mean by AV is, it is nothing but the coefficient of compressibility. What is AV, sir? It is the coefficient of compressibility. So AV is nothing but what, sir? Coefficient of compressibility. So AV is given as by the formula. It is the ratio of decrease in void ratio per unit increase in effective stress. Okay, sir. Similarly, there is coefficient of volume compressibility, which is delta V by V into delta sigma dash, or delta H by H into H into delta sigma dash. So using this formula, you can get delta H, sir. Now, my dear students, already we have height of solids method. Delta H by H is equal to delta E by 1 plus E naught. If you plug in there delta E by 1 plus E naught into delta sigma dash is equal to MV. But what is delta E by delta sigma dash? It is nothing but AV. So MV can also be written as AV upon volume compressibility. Sorry, 1 plus E naught. So what is AV? Coefficient of compressibility. What is MV? Coefficient of volume compressibility. Agree, sir? Now, see, there is a concept called degree of consolidation, sir. It is nothing but the settlement at a time by ultimate settlement. And remember, my dear students, delta H, which is known as settlement, is given by the formula H into Cc upon 1 plus E naught into log of sigma final upon sigma initial. Sir, coefficient of compression index is given by the formula Okay. 1 second, students. Coefficient of compression index is given by the formula change in void ratio upon effective stress by initial effective stress. This is the, sir, remember consolidation happens only in clay layers. Here H is the thickness of clay layer only. And coefficient of compression index CC is given by the formula for undisturbed soils 0.009 into liquid limit minus 10 percentile. Agree? Next, time factor TV is given by the formula CVT upon D square. For single drainage, D will be taken as H. For double drainage, D will be taken as H by 2. I hope you are clear with this session, students. So if you have more and more, if you want more and more sessions for Coal India and Andhra Pradesh Public Service Commission or for Telangana Public Service Commission, please comment in the comment section. And if you want to get these complete notes, please join our Telegram group. There it will be available. So we at IMS GATE Academy are offering the offline, online GATE coaching at Bangalore Jayanagar Center and also at Vijayawada. For students who, if you want to more interested in Andhra Pradesh Public Service Commission, you can visit our Vijayawada Center. It is completely offline, students, and you can get in touch with Vijayawada. It is near to Bench Circle, and we have at Jayanagar and Malleshwaram. We provide theory books, we provide the tests, all India mock tests, everything will be provided according to the student convenience. I hope this session will help you to create, and as I told you, my dear students, see, as I told you, my dear students here, as I told you, if you have more interest, see students, if you have more interest towards these sessions, and definitely I'll do more and more sessions, you are always feel free to ask me in the comment section, or if you can join in the Telegram group, definitely we'll provide the notes. Thank you and all the best.